I want to sketch the graph given all this data. Now what I first want to do is describe what each set of data means. So this set of data right here is basically saying two coordinates. My first coordinate is -1, -2, because at -1 the value is -2. And the second coordinate is saying at 3 my value is also -2. I have two dots. That's all it's saying, which I can plot right now. It's kind of easy to plot those two dots. So -1, -2, and 3, -2. So I got two dots for my graph. Those are pretty easy, basic building blocks. Next part, this is what it's saying. It says the derivative is less than 0 on these two intervals. When I say derivative is less than 0, that's saying slope is less than 0. Isn't less than 0 negative? If I say slope is negative of f, the word for slope negative is also mean decreasing. So isn't my graph doing that, going downhill or decreasing on that those intervals? Now for the second part, if it's greater than 0, does it mean positive? Which means that slopes are positive, which means that slope's going up, which means it's going to be going up, which is called increasing on those intervals. All right, so we're knowing some things. We're interpreting it in better words. Okay, this next piece is saying at 1, something's weird. It doesn't exist. So that basically means it's a vertical asymptote, I'll call it a VA, or maybe a hole, not a 0, but a hole maybe. I don't know, something like that. Something weird's happening there. We got to pay attention to that when we kind of sketch this. Now we have this. The derivative at -1 and 3 is 0. If I say the derivative, that means the slope at -1 is 0, and the slope here is 0. If a slope is 0, doesn't that mean it's a hill or a valley? Isn't that what it means? Yeah. Isn't it called a relative extrema? Oh, aren't these going to be relative extrema of some sort? Don't we have a hill or valley? Oh, does it have to be a relative extrema? No. Could it also do this? Maybe. It could do multiple things, but we know it could be a possible relative extrema. We know these are possibilities if the slope is 0. All right, lastly, second derivative means concavity. So if I say it's greater than 0, I'm saying it's positive. So concave positive is smiling at you. So that's concave up. And if it's negative, wouldn't that be concave down for that interval? So we now have set it all up, and we're now going to use these two dots and what we know to help us piece together a graph that does not contradict anything here. Alrighty, so the next question is, at 1, is it a hole or a vertical asymptote? That's kind of hard to tell. We're just going to go with 1 and see if it works out. I'm going to go with a vertical asymptote. It's because a lot of times, most of the time, they're vertical asymptotes. It's very, very common. So for this one, I'm going to go vertical asymptote. So at 1, let's put a vertical asymptote. Boom, 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 boom. We're going to put that in there and see how this all pans out. Now, here's what I want to start with. There's different places you can start. Totally different places you can start. But let's just kind of think at this dot right here. That's a dot. So at -1, doesn't -1 tell us something right here? -1 and 3, don't we see something right here it tells us? What is it telling is at those points, -1 and 3? Doesn't it also saying the slope 0? So aren't there going to be turnarounds there? Isn't there going to be a turnaround there? And a turn, like a hill or valley, probably relative max or min. Okay. So, which one is going to be here though, at -1? Well, let's look at -1. Left of -1, wasn't it going down? Right of -1 isn't going up. See first derivative test? Wasn't it going down, and then here isn't it going back up? So wouldn't that imply It's doing something like that. Just a small little. Let's see what happens. Are we okay? It's saying it was going down, and then it's going back up. Okay, let's go to this one. We know there's probably Hiller Valley here. Which one is it? Let's see. Left of 3. So left of 3 is this one, right? Are we increasing? And then right of 3, are we decreasing? Let's verify it with the second derivative. On this interval, which interval is -1 in? Is it on this interval or this interval? Which interval is -1 in? Is it on this one right here? And isn't it telling you you're concave up? Is that little thing concave up? Yes, we are. Look right here. Is this number 3? Is 3 in which interval? Isn't it in this one? And doesn't it say concave down? So do they both agree with each other? Is both this and the first derivative, do first and second derivative tests check each other out to be fine with those little curvatures? Okay. So if we extend this out, let's see if everything else holds. Okay, actually, let's not extend it out. Let's just think for a second. If left of -1 is decreasing, doesn't that mean we have to be coming down all the way to that point? So we can extend that. And say, okay, I know that. Okay. And then it's saying from -1 to 1, it's saying it's increasing. So from here to here, isn't it saying it's increasing all the way up to this asymptote? Would that kind of make sense? And are the concavity all the way to 1? Does that follow? Does the concavity stay up, and does it say we keep going? So nothing so far is disagreeing with that look. Nothing I see so far in this information has disagreed that concave up and it's decreasing and then it's increasing. All right? Okay, increasing. And then doesn't it say increasing from 1 to 3? So for this little interval right here, it says it's what? Increasing? And is that with that little arm? So if I bring a line up here, does that make sense? Is there any contradiction there? I don't see any. So nothing seems to contradict that look so far. Nothing seems to contradict it. And then does everything say we should go right, we should go down here, concave down, and decreasing to the right of here? Does anything contradict that? That was a terrible line. Sorry. Does anything contradict that look? When I read through this, do any of these statements, have I contradicted anything? Nothing. We are good. Now, if I put a hole, would I have had some contradictions? I would very likely have to have a contradiction if I would have a hole. Because these two would not kind of meet at a hole spot. It would be kind of weird. Okay? So I would have a weirdness. So asymptote was probably a good choice for this one. And everything fits now. So that is a possible sketch. Is it guaranteed? No. But we got a basic look from a whole bunch of information. And this is where we're going later on when we learn how to sketch the whole thing. You're going to be learning to find all this information, and from this information, piece it together and make a graph.